All right, welcome to this explainer. I am absolutely thrilled you're here today because we're tackling a massive, kind of mind-blowing question. How do incredibly complex products, like, say, the automobile you drive, with its millions of parts working in perfect harmony, or even life-saving medical devices, how do they get manufactured consistently, reliably, and without disastrous failures? Well, it definitely doesn't happen by accident. It happens through a highly structured methodology. And today we're going to unpack the absolute ultimate blueprint for product success.
So here's our roadmap for today. We're going to cover the price of poor quality, jump into the APQP framework, break down the 5 phases of APQP, look at building the ultimate checklist, and wrap up with the next era of APQP.
Okay, let's jump right in. Section 1, the price of poor quality.
Picture this for a second. You spend months, maybe even literally years, developing a brand new product. You've invested massive amounts of capital. The launch day finally arrives, the product hits the market, and it fails. It totally misses customer expectations, parts are breaking down, and the recalls just start rolling in. I mean, think of those massive airbag recalls we've seen on the news, or grounded airplanes. It's a hugely relatable frustration, right? Research actually shows that companies can waste up to 35% of their operating budgets on just inefficiencies and failing to capitalize on opportunities. So what does this all mean? How do we actually prevent this? How do we engineer out these exact disasters before a single part ever even rolls off the assembly line? Which brings us to our solution. Section 2. Enter the APQP framework. So, APQP. It stands for Advanced Product Quality Planning. Basically, it's a project management tool used to develop and produce products that perfectly meet customer requirements through really meticulous planning and error prevention. Honestly, think of it like the ultimate pre-flight checklist, but for manufacturing. The really crucial point here is that this isn't just about inspecting a product at the very end of the line to see if it's broken. No way. It's a completely proactive framework designed to slash costs and boost quality by anticipating problems and eliminating them from the very beginning of the design phase. Now, APQP definitely has its roots deeply planted in the automotive industry. It's actually governed by the super rigorous IATF 16949 2016 quality management standards. But here's the thing. What started in auto manufacturing has become an absolute gold standard across the board. Because of its incredible ability to prevent errors, APQP has spread like wildfire and been widely adopted by multiple high-stakes sectors. We're talking aerospace, defense, medical technology, and pharmaceuticals. Industries where failure isn't just expensive, it's catastrophic. When the stakes are literally life and death, APQP is the tool of choice. Okay, let's dive into how this actually works. Section 3, the 5 phases of APQP. Here is your high-level roadmap. APQP takes this incredibly complex product development journey and divides it into these 5 distinct, totally manageable phases. We move chronologically from planning right into product design, then process design, over to validation, and finally into feedback. So starting off, phase 1 is all about planning and defining the program. During this phase, you've got a multidisciplinary team focusing heavily on capturing exactly what the customer needs and expects. The foundational outputs here are super important. They include your product development timing plan, your overarching design and reliability goals, a preliminary bill of materials, and a preliminary process flowchart. You are laying the absolute correct groundwork here so that every single subsequent step is pointed in the exact right direction. Next up, we hit phase 2, product design and development. This is where those initial goals take a near final shape. We start creating the actual product drawings and test specifications. Crucially, this is where we conduct a DFMEA. That's a design, failure, mode, and effects analysis. You're essentially playing devil's advocate to figure out exactly how the design itself might break. We also establish a prototype control plan. Actually, scratch that. Keep one thing in mind. This specific phase only really applies if the manufacturing organization is responsible for the actual product design. If they're just building to a customer's existing blueprint, they'd probably just skip right ahead to phase 3. And that brings us perfectly to phase 3, process, design, and development. Notice the big shift here. Phase 2 was all about designing the product itself, right? Well, phase 3 is about designing the factory floor process that will actually build that product. If phase 2 asked how the product could break, phase 3 asks how the assembly line could break. We're comprehensively developing a highly effective manufacturing system. The team creates a PFMEA, a process failure mode and effects analysis, to anticipate manufacturing errors. They also develop a pre-launch control plan, workstation instructions, and really map out how they'll measure success. Then we arrive at phase 4, product and process validation. Look, this is the ultimate test. It's showtime. The manufacturer conducts a significant production run under actual, real-world conditions. During this run, the team confirms that the control plans and operator instructions are actually working the way they're supposed to. We get our measurement system analysis, or MSA, results back, just to ensure the very rulers and sensors we use to check quality are actually accurate. And ultimately, the customer validates that both the product and the manufacturing process perform exactly as intended. Now, here is kind of the most interesting part of the whole framework. Phase 5, feedback, assessment, and corrective action. Unlike the previous steps, Phase 5 isn't sequential. It is literally the only phase that runs continuously from the very start to the absolute finish of the program. It tracks lessons learned, assesses effectiveness at every single stage, and deploys countermeasures immediately if a concern ever pops up. It's basically the engine of continuous improvement that keeps the whole APQP process alive and adaptive. All right, let's move out of the theory. Section 4, building the ultimate checklist. And this brilliantly illustrates a key point. APQP checklists are built and managed by cross-functional teams, or CFTs. You literally cannot do this in a silo. You need representatives from engineering, manufacturing, quality, procurement, and distribution, all sitting at the exact same table. This amazing diversity of expertise ensures that, say, an ambitious design engineer doesn't accidentally sketch up a part that the manufacturing team physically can't build or that procurement absolutely cannot afford. The power of this APQP checklist, when executed by that cross-functional team, is just massive. A really well-structured checklist identifies every single task, establishes checkpoints, and sets hard timelines. It ensures that customer requirements are identified super early and verifies that product validation is completely airtight. It transforms what could be a chaotic, massive undertaking into a really rigorous step-by-step guarantee. By referring to these checklists, teams ensure no step is ever missed, which minimizes the risk of costly mistakes and upholds those super strict industry standards. Finally, let's look at where this is all heading. Section 5, the next era of APQP. So back in March 2024, the Automotive Industry Action Group, the AAIG, released the third edition of the APQP manual. And the biggest update by far is the evolution of the control plan. Historically, the control plan was totally integrated directly within the APQP manual itself. But in this third edition, the control plan was entirely removed and made into its own standalone document, known as CP1. Why? Well, think about it. The industry is facing incredibly high automation today, an aggressive shift toward electrification, and entirely modern, highly complex mobility definitions. Separating the control plan just allows for way more detailed, focused guidance on things like safe launch requirements and automated manufacturing applications. And there's actually a lot more. The framework is rapidly modernizing to handle today's really complex global supply chains. The third edition brings agile management right to the factory floor. It introduces rigorous new sourcing protocols, strict change management, and a massive emphasis on part traceability. It also throws in new APQP program metrics and super robust risk assessment mitigation plans. Overall, it's a comprehensive upgrade focusing heavily on the why behind the what and the when. Always remember this quote: continuous improvement involves actively seeking opportunities for improvement and making small modifications over time. That perfectly summarizes the core philosophy of APQP. It is the relentless, highly structured pursuit of manufacturing perfection. It's not about being absolutely perfect on day one. It's about having an incredibly solid system that catches imperfections before they ever reach the real world, and then constantly, continuously refining that system. So I want to leave you with this final, kind of provocative thought to chew on. As our global supply chains grow increasingly complex every single day, is your organization simply detecting errors after they've already happened? Or are you using methodologies like APQP to engineer them out of existence entirely from the very beginning? Thank you so much for joining me for this explainer. I really hope this structured look at APQP leaves you eager to optimize your own processes and build better, safer, and much more reliable products. See you next time.